Alright, question 6. Consider the following scheme of reactions. Yeah. Okay, so you've got a whole, what looks like a massive set of molecules there. Well, the first thing to realise is we're looking at propane and alkane. We're forming we're adding a chlorine to it. We look at it, we're changing it to an alcohol. We've got over here primary alcohol, a secondary alcohol. There's our primary and there's a secondary alcohol. And then we come to our real crunch. We've got a propanal and a propanone. Propanal is an aldehyde, so the very last carbon's going to look like this. Propanone is a ketone. So what we've got, and because this is propan-2-ol, the second carbon, let's get rid of that. It's going to be there. Alright. So to state the type of structural isomerism shown, it's a functional group isomerism. Because they are quite different. They have very different reactions. Well, I might as well say it here. Propanal can go on to form, during oxidation, it can go on to form carboxylic acid, while ketones can't. So that's the big thing. And it's also the reason why you can test for them. My favourite is Tollens reagent because I like silver. So one way of testing, it says a chemical test can be used to distinguish, and they love that, between separate samples of propanal and propanone. Identify suitable. You can have Tollens reagent or Fellings solution or Fellings or Benedict's. Pick one. Oh god, that's going to come off screen. Let's cross that out. That's what Benedict's. But you can have either one of those three. Personally, I prefer Tollens because it uses ammoniacal silver nitrate. Yeah, I just use that, while studying. So it's one thing that sticks in my head. So with propanal, what you get, and remember it's the aldehyde you get from this silver mirror. Yeah. So with propanal, with Tollens or ammoniacal silver nitrate, you get a silver mirror. And with propanone, no change. And that's it. But you have to remember, and the way I kind of think about it is that if I've got an aldehyde and I change it to a carboxylic acid, I'm going to have 1, 2, 3, 4 bonds. You see, I'm going to need an OH group on the ketone to change that to a carboxylic acid, but you can't, because you end up with 5 bonds around your carbon atom. And it's a nice one, it's classic, and it also comes up in your first year at university. So, that's question 6A and B.